These are notes from Elham's Math 60 for Thursday, May the 7th, section 10.4, page 891. This is the last section of chapter 10, in fact, the last section of the entire book. A quick word about problems 15 to 21. It says to graph, don't graph them, just do it by elimination or substitution, which I'll illustrate how to do 15 and 17 in these problems. Okay, you have a system of equations. Once again, you have two equations with two unknowns, two equations, two unknowns, two equations in x and y, two equations in x and y, and we're trying to solve. We're not going to do any graphing, just elimination or substitution. Here's 15. X squared plus y squared equals 9. Y minus x equals 3. I'll do this one by substitution. It seems to be the best. Solve for y. I'll add x to both sides, so y equals x plus 3. Now I'll pick up this expression and plug it in for y right here. So it looks like x squared plus, here's y squared, x plus 3 squared is equal to 9. And then I try to solve that equation. So x squared plus, this stuff is x squared plus 6x plus 9 equals 9. Subtract 9 on both sides, that gives me a 0. This becomes 2x squared plus 6x equals 0. Factor out a 2x. 2x times x plus 3 equals 0. So by the zero factor property, either this is 0, which means x is 0, or this expression in parentheses is 0, which means x equals negative 3. Plug back in to find y. Y is x plus 3, so 0 plus 3 is 3. Negative 3 plus 3 is 0, so the ordered pairs are 0, 3, and negative 3, 0. So in other words, if I were to graph this with 100% accuracy, it's a circle. If I were to graph this with 100% accuracy, it's a line. This is where those two graphs would touch at 0, 3, and negative 3, 0. 17 is best done by elimination. You can see how it's all nice and lined up. X squared, y squared number, x squared, y squared number. In fact, a lot of the numbers look the same. So I'll just add directly. You might recall a while back we did elimination by addition. If you add directly, it looks like the y squareds cancel out. So 18x squared equals 288. Divide both sides by 18. X squared equals 16, which means x is equal to plus or minus 4. And in this particular case, since all I see is x squared and y squared, no matter if I plug in either a 4 or a negative 4, when you square it, it's going to be 16. So that gives me 9 times 16 plus 16y squared equals 144 if I plug in the top equation. 9 times 16 is 144. 144 plus 16y squared equals 144. Subtract that 144. 16y squared equals 0. Divide by 16. Y squared equals 0, which means y is equal to 0. So I have plus or minus 4 for x and 0 for y. So negative 4, 0, and 4, 0 are my solutions. Then up here for 23, again, looks like it's best done by substitution. X squared plus y squared equals 5. X plus y equals 3. First, I will subtract x, so y equals 3 minus x, and then take this expression and plug it back into here to do my substitution. So x squared plus y squared, here's y, 3 minus x, it says so here, equals 5. So now I just have a single letter, x. X squared plus, FOIL this out, 9 minus 6x plus x squared equals 5. It's going to be a quadratic equation, so I'll put everything on the left side. I'll subtract 5 on both sides. X squared plus x squared is 2x squared. There's a minus 6x. 9 minus 5 is 4. Factor out a 2 times x squared minus 3x plus 2 equals 0. Factor this trinomial into 2 times x minus 1, x minus 2 equals 0. Okay, which means one of these is 0. 2 cannot be 0. X minus 1 equals 0 means x equals 1. X minus 2 equals 0 means x equals 2. And then I plug back in here. If x is 1, y is 3 minus 1, which is 2. If I plug in 2, 3 minus 2 is 1. So my points are 1, 2, and 2, 1. 31, again, looks like it's better to do this by elimination. It looks like x squared, y squared number, x squared, y squared number. Just add them directly. So if I add directly, y squared drops out. 2x squared equals 8. Divide by 2, x squared equals 4. Do the square root property, x is plus or minus 2. Okay, and I notice whether I put a positive 2 or a negative 2, when I plug back in, I'm still going to get 4. So plug in, call this thing 4. 4 plus y squared equals 20. Subtract 4, y squared equals 16. Take the square root property, y equals plus or minus 4. So I have plus or minus 2, comma, plus or minus 4, which is actually 4 points. Either x and y are both negative, or x and y are both positive, or one is positive and one is negative. That's what I have here. So negative 2, negative 4, negative 2, 4, 2, negative 4, or 2, 4. Here is 37, a little bit harder. Ignore the red. The original did not have the red. It was x squared minus y squared equals negative 5. 3x squared plus 2y squared equals 30. So it looks like, again, I want to do elimination, but you might recall for elimination, I can't do it until either the x squareds have opposite coefficients or the y squareds have opposite coefficients. So to accomplish that, I put in red, I'll multiply both sides of the top equation by 2. Multiply this by 2, multiply this by 2. This gives me 2x squared minus 2y squared equals negative 10. Copy the second equation, and then I notice that if I add directly, the y squareds drop out. So add them up, 5x squared equals 20. Divide by 5, x squared equals 4. Do the square root property, x is equal to plus or minus 2. And plug back in. This time I wanted to do the second equation just because they're all positive. So again, whether I plug in a positive or negative 2, when you square it, you get 4. So 3 times 4 plus 2y squared equals 30, plugging into the second equation. 3 times 4 is 12. Subtract 12, 2y squared equals 18. Divide by 2, y squared equals 9. So by the square root property, y is plus or minus 3. So x is plus or minus 2, y is plus or minus 3. So again, that gives you 4 possibilities. Both negative, both positive, or one negative and one positive. So negative 2, negative 3, negative 2, 3, 2, negative 3, or 2, 3. And finally for 29, x squared plus y squared equals 30, y equals x squared. Looks like the best way to do that one, again, is by substitution. So I put x squared right in here. So that gives me x squared plus y, which is x squared squared equals 30. So this gives me x to the fourth. X to the fourth plus x squared minus 30 equals 0. I will make a substitution. Let x squared equal t. So that way, if I call this t, this is like t squared, because x to the fourth is x squared squared, or t squared, plus t minus 30 equals 0. Factor t plus 6, t minus 5 equals 0, which gives me t is equal to negative 6, or t equals 5 by the zero factor property. But t was equal to x squared, so I plug back in x squared equals negative 6. That can't happen. We're only doing real solutions now, so we don't want to do any I stuff. So that's out. X squared equals 5 means x is plus or minus the square root of 5. So x is plus or minus the square root of 5. Since y is equal to x squared, that means y is just equal to 5. So I have negative radical 5, comma 5, or positive radical 5, comma 5 as my solutions. All right, so that does it for Melham's Math 60, Thursday, May the 7th, section 10.4, the last section of the book. So tomorrow, Friday, May the 8th, will just be a quiz. I'll just give you a quiz on graphing the so-called conic sections, which are the circle, ellipse, parabola, and hyperbola. I'll give you one of each. And then Monday will be the last regular test, so that will be this coming Monday the 11th, will be the chapter 10 test.